We're going to be talking today about angles of elevations and angles of depression. Basically, these are word problems for trigonometry. And so you've done some word problems. I just haven't called them with these phrases, angles of elevation and angle of depression. When I'm talking about an angle of elevation, if you think about an elevator, it takes you up. So an angle of elevation is when an observer is looking up. The angle is between the horizontal line and the observer's line of sight to an object. So if you notice right here, this is where the person is looking, so it is my angle of elevation. Basically, this is going to help you figure out where to put the theta or the angle marking in word problems. Its opposite is called an angle of depression. When you think about depression, sometimes you think about sadness, which is looking down. So it's when an observer is looking down and the angle is between the horizontal line and the observer's line of sight down to an object. So if we look at this image here, if we were standing on top of this cliff, this would be our angle of depression. So now your job is to not only understand the word problem, but to also put the angle where they're supposed to be. Horizontal lines are parallel, so the angles of elevation and angle of depression are actually congruent by the alternate interior angle theory. So really, as long as you get the angle right, for the most part, you'll be able to solve these triangles correctly. But we're going to make sure we know where to put the different angles for elevation and depression. So first, let's identify and label the angle of elevation and or the angle of depression in each figure. So a person is looking at the top of a Ferris wheel. If they are looking at the top of the Ferris wheel, that means they're looking up. Does that mean it's an angle of elevation or an angle of depression? Elevation. So this one right here, this theta, is the elevation. That's not how you spell that word. Elevation. That's where we would put theta, between the person's eyes and the top of the Ferris wheel. That's describing an angle of elevation. For number 2, it says a helicopter pilot finding the best angle for landing. So the person who's looking is here in the helicopter and they're looking down to land. Does that make it an angle of elevation or depression? Depression. Now you will put that angle of depression from the horizontal line looking down, and it's going to be really tempting to put it right here. That's not where he's looking. He's looking from straight ahead down. So this is the angle we're talking about for angle of depression. Okay, angle of elevation is usually really easy because it's from the ground looking up. Angle of elevation is usually from an invisible line looking down, but it's a horizontal line straight out of somebody's eyes. Now this is going to help us solve problems using our trig. Now as a reminder, if you are missing a side length, we learned last time with that card sort that we did, finding a missing side means that you are using regular sine, cosine, and tangent. And if you're finding a missing angle, that's when you do the inverse sine, cosine, and tangent. So if we look at just some of these examples to remind ourselves what that looks like, in number 3, it says you are measuring the height of a spruce tree. You stand 45 feet from the base of the tree. You measure the angle of elevation from the ground to the top of the tree to be 59 degrees. Okay, let's label our little picture here, which, by the way, if there's no picture drawn for you in these problems, you're going to want to draw a picture. It says that I stand 45 feet from the base of the tree. Where should I put the 45? On the ground, right? So this is going to be 45 feet because it's from the base of the tree to me. It also tells me that the angle of elevation from the ground to the top of the tree is 59 degrees. Where do I put 59 degrees? To the top. Okay, but from where to where? From the ground to the top of the tree, right? So I'm putting that angle of elevation here, from the ground to the top of the tree. That means this right here is 59 degrees. Inside, it's the angle of elevation, so it's a corner angle number from the ground to the top of the tree. The question here says, find the height of the tree to the nearest foot. So we're looking for the h, which you can't really see because I just wrote that over the tree. We're looking for the height of this tree. Once we have it drawn, we're done even thinking about an angle of elevation depression. We go back to our regular trig things that we know. Compared to this angle 59, let me rephrase. Do we know the hypotenuse for this triangle? No. We can't use any trig function that involves hypotenuse, so which trig function are we going to use? Tangent. So when we set this up, we will say the tangent of the angle, which is 59 degrees, should be equal to, and if you read the patterns, it should be opposite over hypotenuse. I'm so sorry. Opposite over adjacent. So compared to the angle 59, what is opposite from it? H. Opposite is like all the way across the triangle. Opposite from the angle is H. What is adjacent or touching the angle? 45. We can solve for H. The way that we did this before was to make this into a proportion, cross multiply and solve. H times 1 is H. 45 times tangent of 59 is 45 tangent of 59 degrees. At this point, you turn to your calculator, and since you just turned your calculator on for the first time, what should you do with it before you type stuff in? Change it to degree mode. The class before you uses radians. It will be in the wrong mode for you every single time. We're going to round this to the nearest foot, which means whole number. So what is the height of this tree? Yeah, my calculator is going to say 74.89 whatever, which means we would round that to 75 feet. Which is really cool. So in real life, this is a way trig is used. There's a tool, I forgot the name of it, but basically you point it at stuff and then you hit a trigger and it tells you the angle that you're looking at it. So we can actually do this. Have y'all ever seen the people on the side of the highway with those little, stands that are like looking through, they're like looking through a little thing on the side of, you know what I'm talking, they're called surveyors. Does anybody know what I'm talking about? No. Okay, when y'all are about to start driving, which means you should pay more attention to the things that you see on the side of the road, you'll eventually see surveyors there, and this is what they're doing. They're measuring the different topography of the ground by measuring what are the angles to different things they can see in that little machine, which is pretty cool. So this is like actually the way that trig is used in real life. Let's try another problem. Number 4 says a person is snorkeling and they see a turtle on the ocean floor, cool, at an angle of depression of 38 degrees. Interesting, angle of depression. She is 14 feet above the ocean floor. How far from the turtle is she? Okay, so the first thing we're given here is the angle of depression being 38 degrees. Angle of depression means that it's from the snorkeler looking down. So on my triangle, I need to go from the snorkeler looking down. That's where the 38 degree goes. From the snorkeler looking down. Now that feels weird because that angle is not inside of my triangle. But if you remember what we did with parallel lines and systems of parallel lines, this angle and this angle should be the exact same. So even though I wrote 38 degrees up here, because that's the angle of depression, that means I can also write 38 degrees here from the ground of the turtle up to the snorkeler. Those are going to be the same measurement. That's because they are alternate interior angles. Now, if we continue with this problem, we got to label at least one more thing. It says the snorkeler is 14 feet above the ocean floor. Where should I put the 14? The height, yeah, from the ground of the ocean floor up to the snorkeler. So that means that this would be 14. We are trying to find how far from the turtle she is. Now we are trying to find how far the snorkeler is from the turtle, which means we are actually looking for this distance right here. The direct distance from the snorkeler to the turtle. For this problem, do we know or want to know the hypotenuse? So we're going to use one of the trig functions that involves the hypotenuse. compared to this angle 38 degrees, is 14 the opposite or the adjacent?
Is it touching a 38 or is it across from it?
So it's opposite. So if we're involving the opposite and the hypotenuse, which trig function are we going to use? Sine. Very good. So we're going to do the sine of 38 degrees is going to be equal to the opposite, which is what? 14 over the hypotenuse, which is x. Again, we solve this trig function by setting up a proportion. 14 times 1 is 14. X times sine of 38 degrees is x sine of 38 degrees. Is this something I can type in my calculator right now? Is x by itself? No, so it's not something I can type in my calculator yet. But to get x by itself, all last week, what did we do to solve for x?
Put 14 sine 38.
Well, but they're not next to each other. We would if the 14 was next to sine of 38. We divide, so we're going to divide both sides by sine of 38 degrees, basically so that this sine of 38 degrees is going to cancel out and leave the x by itself. Remember, if you're solving for the denominator, you divide. If you're solving for the numerator, you multiply. So now, just to make this clear in our notes, we have x equal to 14 over sine of 38 degrees, and that is something we can type in my calculator because it's x equals. So y'all go ahead, we're going to round this also to the nearest foot, which is a whole number. 14 divided by sine of 38. We're already in degree mode, hopefully, so you don't need to check that. So just type that straight in. We should get approximately 22.7, and so you round that to what feet? 23 feet, which is really close to that turtle. If I was snorkeling, I'd be real excited to be close to a turtle. Our last question for the day, it says an Air Force pilot is 1,500 feet above sea level and must descend or go down over a distance of 9,000 feet to land on an aircraft carrier. At what angle of depression must he descend to accomplish this? Okay, this is a different kind of question than the top two only because we're going to be solving for the angle. It didn't ask me what was the height or what was the distance. It asked me what is the angle. So we need to label this image. In this image, it says the Air Force pilot is 1,500 feet above sea level. Above meaning that's my height. So I'm going to put the 1,500 feet as the height of this right triangle that I'm drawing. And he must descend over a distance of 9,000 feet to land smoothly. A distance horizontally of 9,000 feet. So we're going to put the 9,000 right here. Because he's descending over this distance. Over it, meaning this way. Yeah, okay. At what angle of depression must he descend to accomplish this? So we are actually looking for the theta. We are looking for this angle. But my numbers are over here on this right triangle. And if I want this angle of depression, where else can I write theta so that it's in the same, it's congruent? Well, look up at this one. If 38 degrees was my angle of depression, where else did I write 38 degrees? So where else can I write theta? There we go. Now we have an angle inside my triangle with the numbers, and we're going to be able to solve. Now, which trig function am I going to use here? Do I know the hypotenuse? No, so I shouldn't use the hypotenuse at all. Which trig function am I going to use instead? I will eventually use an inverse, but we're going to set it up as tangent. So if we have tangent of theta is equal to the opposite over the adjacent. What is opposite to theta? 1,500. What is adjacent or touching theta? 9,000. Now Joseph is right. If we are looking for theta, that means we want to get theta out of the tangent function. The only way to do that, Joseph, you're right, is to do inverse tangent on the other side. So we're going to do inverse tangent of 1,500 over 9,000. As a reminder, you'll notice all of the inverse buttons are right above the regular sine, cosine, and tangent, but they're blue. So to get inverse tangent, we press second, we press tangent, and then you can type in that fraction. 1,500 divided by 9,000. When we do that, what do we get the value of theta to be? And it asks us to round to the nearest degree. I get 9.46 when I put this in my calculator. Do y'all agree? But if we're rounding to the nearest degree, is that going to be 9 or 10? 9.4 would round to what? Oh my gosh, 5 or more, raise the score, 4 or less, let it rest. We're going to let that rest at 9 degrees. So in these problems for angles of depression and elevation, they're complicated because they require you to set them up correctly, but then they're just like the problems we've done in the past where we're either solving for a side length, like this one, or solving for an angle, like this one. If you're solving for an angle, you're going to use the inverse. If you're solving for a side length, you'll have to set up your proportion. I know y'all liked these problems better when you were looking for an angle, so be looking for those that ask you for the angles of a depression and elevation because you like those better.